We're continuing on with our process of finding a feasible region and then using that region to find the maximum and minimum values of the objective function. And the objective function is always named z. It will be representing something in particular for you, but we always use z. And there's a reason for that, but it's not particularly important in this class. So the very first thing I'm going to do is label the axes because Professor Hill is really picky about that and I don't want to forget. So then I'm going to look at equation 1. Well, it's inequality, but fortunately it looks like it will be a good candidate for the intercept method because the 2 and the 3 divide evenly into 6. So when I'm using the intercept method, I make a little table and I say when x is 0, then I can see that y must be 2. And when y is 0, x must be 3. So again, I'm going to use a scale where each box is a half because it has the effect of expanding the graph and making it easier to see what's going on. If you have a really tiny graph, it's going to be really hard to tell where your shaded region is. So I have 0, 2 for my y-intercept and 3, 0 for my x-intercept. So then I'm going to graph my line. And this is line 1, just so I can keep track of it. Okay, then my second line, I'm going to work over here on the right. I have 4x plus y is less than or equal to 6. So 4 doesn't divide evenly into 6. So I'm going to go ahead and subtract 4x from both sides to get it in slope-intercept form. So I have y equals negative 4x plus 6. Well, hopefully your graph is a little bigger than mine because I can see I'm going to run out of room here and I'm going to go ahead and put a 6 up here. But know that I'm not demonstrating how to do it. I'm telling you how to do it, but I want you to make sure your graph fits on your grid. So I have my y-intercept of 0, 6, and then I go down 4, 1, 2, 3, 4, and over 1. Down 4, 1, 2, 3, 4, and over 1. So that's my second line. And you're going to use a straight edge. Any kind of straight edge will do. A ruler is great, but it can be just a piece of cardboard. It's fine. And there's my second line. So let me back up to my first line. Say, oh, I need to do the inequality part of this. So let me test 0, 0, because I find that way easy when we're in the general form of the equation of the line. And you say, what if x is 0 and y is 0? Do I get a true statement or a false statement? And I get a true statement. So that means as it's relative to line 1, I need to shade towards 0, 0. So I'm going to make my arrows towards the side where 0, 0 is. Okay, then my second line, I have y is less than or equal to the points on the line. So I can use the above-below method and say, clearly I want points below the line because I want y values that are smaller, and you find those down lower. So I'm going to go ahead and make some arrows showing that region. Okay, so when you have two lines making kind of a squashed X like this, it creates 4 regions. So there's this region over here to the lower left, region over here to the upper left, a region to the upper right, and a region to the lower right. So it's one of those 4 regions that's going to be the solution area, and you have to pick the right one. by looking at the arrows, saying which region has arrows of both colors. So it's going to be this four-sided piece that I'm outlining with black, and we have X is positive and Y is positive. So that gives us the vertical side and the horizontal side. And then it's this shaded region inside. So the shaded part is the feasible region. This is where it is possible to operate given these conditions. So now we have our objective function, and we need to evaluate it at each corner point. Well, that means we're going to have to find the corner points. So I like to label my corner points. So the first one is going to be the 0, 0 point. Then I go clockwise around the shape to make sure I don't miss any of the corner points. So then I see the y-intercept of line 1 is going to be a corner point. Then I see the point of intersection of the two lines is going to be a corner point. And then the x-intercept of the second line is going to be one of the corner points. So what I need to do is find all those points and then evaluate this objective function at each of those points. So you see that the formula has an x and a y in it. So it means you're going to plug in the x and y coordinates of each of the points. So I can see easily what point A is. That's 0, 0. I can easily find the y-intercept of a line. It's going to take me a little bit of work to find the x-intercept of the line. And then point C looks like it's going to take me the most work because I have to find the point of intersection of these two lines, 2x plus 3y equals 6 and 4x plus y equals 6. So recall that finding the point of intersection is the same as solving the system of equations. So you can use whichever method you like the best. For this system, I would notice that I have 2 x's in the first equation and 4 x's in the second equation. So I would multiply both sides of the first equation by -2 because I see that that will make the x's eliminate. So I'm going to write what I get down below, -4x minus 6y equals -12. So the x's are going to eliminate. That's why I picked the multiplier I picked. Y minus 6y is -5y. Then 6 minus 12 is -6. So I'm going to divide both sides by -5 and get y equals 6/5. Now this problem was not given with decimals or fractions, so you're really free to use whichever form as long as it's exactly the same. So for example, 1/3 does not equal 0.33, so don't use this as an exact replacement because it's not exactly the same. But 6/5 is exactly the same number as 1.2. So you're welcome to use either one, whichever you're more comfortable with. So then once we find the y coordinate, then we need to find the x that goes with it. We can use either one of the equations. The bottom one's closer, so I'm going to use it. So I have 4x plus the y value I've figured out now of 1.2, and that equals 6. So I'm going to solve for the x and get 4x equal, looks like 4.8. Divide both sides by 4 and get x also equals 1.2. So the point of intersection is 1.2, 1.2. So let me start making my list of corner points, and organizing your work and your information is going to be a key to doing well in this whole class, but especially this section and chapter. So I had corner point A was 0, 0. Corner point B we said was the y-intercept of line 1. The y-intercept was 0, 2. Now we have point C, which is the intersection point of the two lines, 1.2, 1.2. And then we need the x of line 2. So the x-intercept happens when y is 0. So the x-intercept is when y is 0. So we're going to take the equation of that second line that was 4x plus y equals 6. 4x plus y equals 6. And we're going to put a 0 in place of the y and say, well, the x-intercept is going to happen when x equals 3/2 or 1.5, since that's exactly the same. So we can see that our fourth corner point is going to be 1.5, 0. And then I always look at my picture and make sure the math I'm doing makes sense with the picture. That looks like it agrees with the picture and makes sense. So now we're going to look at our objective function. Z equals 4x plus 3y. And we are going to evaluate our objective function at each of these points. So for point A, z equals 4 times 0 plus 3 times 0. So that's going to give me 0. Then for point B, z is going to be 4 times 0 plus 3 times 2, or 6. Then for C, I'm going to have 4 times 1.2 plus 3 times 1.2. And that's going to give me 8.4. And then for point Z, for point D, I'm going to have 4 times 1.5 plus 3 times 0. And that's going to give me 6. So we were asked to find the minimum value of Z. So 0 is the min value of Z on this feasible region, because all we have to check is the corner points. So then we can also see that 8.4 is the max value of Z. So I want to give you some sample sentences because you're going to be asked in 7.3 to interpret scenarios. And so you're going to be saying something about the minimum value of Z, whatever Z is representing, is 0. It occurs or happens when x equals 0 and y equals 0. So in an actual problem, you're going to fill in the maximum value of the investment, or whatever Z is standing for. And it happens when the amount you invest in account 1 is 0 and the amount you invest in account 2 is 0. So X is going to represent something, Y is going to represent something, and Z is going to represent something in the next section when you're actually solving linear programming problems. So let me give you the other sample sentence, which is the maximum value of z is 8.4, it happens or occurs when x equals 1.2 and y equals 1.2. So if you were maybe talking about profit, you might be saying when you invest 1.2 million in this stock and 1.2 million in this mutual fund, your profit is maximized, and that maximum profit is $8.4 million. So that's all there is in this section. It's practice doing the skills you're going to need when you're solving a linear programming problem. You'll see the next section is all word problems. So make sure and give yourself lots of time to be able to translate from the words into the inequalities and then find the objective function and solve the linear programming problem.